For this lab, the object I chose to use was a red Solo cup with a plastic bag attached to the top of it acting as a parachute. I chose this combination because I wanted a clear, visible object to track using Tracker, as well as something to give the cup enough drag force to be noticeable. I was also able to find a drag coefficient for a plastic bag fairly easily online, which made creating my models much easier. In this first video, we see the original clip of me dropping my object. As you can see, the object started from rest and fell until it hit the ground. This next clip is my original clip once put through Tracker. As seen here, the position versus time graph created tracking my object through Tracker shows the object picking up speed in the negative direction at an increasing rate before slowly becoming more constant. In this next clip, we see a video of my first computational model, which projected the position and velocity of my object, only taking into account the force of gravity. Because the only force here is gravity, and since gravity remains constant, the object increases velocity with constant acceleration since there is no opposing drag force taken into account. In my second clip, you can see that with drag force taken into account, the object still begins to increase velocity at the start, but as time passes, the change in velocity begins to decrease, and velocity begins to approach a constant value. This would lead us to assume the object is reaching its terminal velocity, which should happen to objects after a certain period of time when experiencing freefall. At this terminal velocity, the drag force is very close to the force of gravity, which means there is little to no net force acting on the object, since the drag force faces in the opposite direction of gravity. In this next image, we see the position versus time graph of my Tracker data compared with the two computational models that I created. As you can see, Model 2 more accurately predicts the motion of my object. This is because it takes into account the drag force of my object. Model 1 initially follows a similar path to the actual motion of my object, but because it does not take into account drag force, the velocity and position both increase at a faster rate than the actual motion. In this lab, we only accounted for drag and the force of gravity, but there are other possible forces that could have been applied. For example, if the object was thrown down, we would have taken into account the initial force of the throw. This force, however, would not have any effect on the terminal velocity of the object. This is because the force would be instantaneous and would not remain constant on the object through its fall. Therefore, the terminal velocity would stay the same and occur when drag force equals the force of gravity.